HW19 is the last of Chapter 1, or what they call Chapter 1. Again, we're solving equations that have fractions, and so as Dan reminded me last time, you got to check for your exclusions of things that you can't have for answers. So we might as well check at the beginning. We can't have a negative... I don't know why this pen won't stay on the right pen. We can't have a negative 6 in the denominator, and we can't have a negative 1 in the denominator. So if we solve the whole thing, which will take a while, and get either of those two solutions, we'd have to take them out because division by 0 is undefined, and so we can't have a 0 in the bottom of the fraction. So I'm going to check for them right away so I don't forget to check at the end. Again, we want to multiply by our common denominator to get rid of the fraction. Our common denominator is going to include both the w plus 1 and the w plus 6 so that we can eliminate the fractions. So we're going to have 4 times w plus 1 and w plus 6. On this one, when we multiply by the w plus 1 and the w plus 6, the w plus 6 cancels. So we're going to have plus 5 times w plus 1. On the other one, both of them are going to cancel. That's going to cancel there, that's going to cancel there. There's a minus sign there, so I'm going to have a minus 6 on the end. Now personally, I like to FOIL this first before I multiply by the 4. Not that it really should make any difference, but that's the order I'm going to do it in. So I'm going to multiply that out. So w times w is w squared. The outside plus the inside would be 6w plus 1w, so 7w in the middle. 1 times 6 is 6. So I've got 4 times w squared plus 7w plus 6. I'm then going to distribute that out. So 4w squared plus 28w plus 24. So I got that first part done. The next part, distributive property, plus 5w plus 5 equals my minus 6. Now I have a quadratic expression. I know I have it set equal to 0, so I'm just going to go ahead and plus my 6 over here before I start combining all my terms, because I'm going to have to combine it in there sooner or later anyway. So we have a 4w squared. We have 28w plus 5w, which would be 33w. And we have 24 plus 5 plus 6, which looks like it's 35. And if I make a mistake somewhere, holler at me so I don't go through the whole problem and get to the end and you say, I have something different. We have to solve this by factoring. So we have to be careful again. If I have a 4w squared, it could be 4w and w, might be 2w and 2w. You really just you don't know, you're just going to guess and check. I'm going to start with my 4w and my w. Both my signs are pluses, so plus and a plus. Factors of 35, probably 7 and 5. I want to get 33, so I'm going to try the 7 over there and the 5 in the middle. 28 plus 5, sure enough, adds up to 33, right? So then I'm going to solve these. If 4w plus 5 equals 0, again we've got to minus the 5 and divide by the 4, so we get negative 5/4. And if w minus or plus 7 equals 0, we've got to minus the 7, so negative 7. Didn't get either value that's restricted, so both of those values should be okay. So negative 5/4 and negative 7 should be my solutions. So lots of spots in there where you can make silly little mistakes. Just try to take your time. And so again, number 2, if I check my restrictions first, what 2 values can't I have in the denominators? Negative 1 and negative 2. So if I would get either of those answers, I'd have to cross them off and say can't have those. Multiplying by my common denominator, I'm going to use both the y plus 1 and the y plus 2, so I'm going to have 8 times y plus 1 and y plus 2. I'm going to have minus 1, and here the y plus 1 would cancel out, so I have to multiply by the y plus 2. the opposite one. And then I have a 5. The y plus 2 would cancel out, so I'm going to multiply that one by the y plus 1. So again, I'm going to FOIL that out first. Y times y is y squared. My outside plus my inside would be 2y plus 1y, so I'm going to have 3y in the middle. And then 1 times 2 is 2. So 8y squared plus 8 times 3 would be 24y plus 8 times 2 is 16. Using my distributive property here, I'm going to multiply by -1. I'm going to leave the 1 there just for fun. -1y minus 2 equals, on the other side, 5y plus 5. There. And again, since I know I have to set it equal to 0, before I combine my like terms, I'm going to minus my 5y and minus my 5, and then I'll just combine them all at the same time. So we have an 8y squared, 24y minus 1y minus 5y would give me, whoops, positive 18y. And then I have a positive 16, a minus 2, and a minus 5, which would give me a positive 9. Did I get all that right? Sure, you're just going to believe me, huh? Factoring that looks interesting to factor. I'm going to guess it's not 8 and 1. I'm going to try 4 and 2. 4y and 2y, plus and a plus. And I want to get 18 in the middle. If I do 3 and 3, I'm going to get 12 plus 6, which, hey, is 18. The more you do, the easier it gets to figure out what you're doing. Don't think I'm magic. I'm not. I've just did 9 million problems. So if 4y plus 3 equals 0, I'm going to minus my 3 and divide by my 4. So -3/4 would be the solution on that one. If 2y plus 3 equals 0, I'm going to minus my 3 and divide by the 2. So -3/2. Didn't get either of my exclusions, so -3/4 and -3/2 should be my 2 answers. You guys get to help me with the next one. Number 3 then. First of all, if I pick out my exclusions, what values can't I have for answers? You know how we're getting them? We're looking at the denominator and figuring out what values give us 0. So on this one I can't have 1, and on this one I can't have -2. So if I get either of those 2 answers, it would give me 0 on the bottom of my fraction, and that's why I can't have those. Hit the board with my hand. So, multiplying by my common denominator. My common denominator, v plus 2 and v minus 1. What would I have there for my first part of my equation?
-3 v plus 1
v plus 2. So the -3 is multiplied by both of those 2 things, plus the 1 is going to be multiplied by, I'm going to be able to cancel out the v minus 1, and so I'm just going to multiply it by the v plus 2. So technically I'm taking everything times v minus 1 and v plus 2, but on the fraction ones I should be able to cancel at least one of them out, if not both of them out, right? Equals, on the other side they're both going to cancel, right? I'm going to cancel the v minus 1 and the v plus 2, so I'm just going to get the 3. So if you FOIL out v minus 1 times v plus 2, what would you get there?
V squared plus v minus 2.
V squared plus v minus 2. So distributing my negative 3, I have negative 3v squared minus 3v and plus 6 then. Over here, we're going to have a plus 1v and a plus 2 equals our 3. Now on this one, because I don't want to have the negative 3v squared, I'm going to move everything over to the other side. So I'm going to add my 3v squared, add my 3v, minus my 6, minus my 1v, and minus my 2. Oops, 3v squared. So I have 3v squared, I've got 3v minus 1v, which would be 2v, and then I've got 3 minus 6 minus 2, negative 5, huh? So factoring that, 3v and v we know has to be the 3v squared, right? My signs in this case are going to be what kind of signs am I going to have in here? If the end is negative, we've got one of each, right? One plus and one minus. And factors of 5, well, we know that's a 5 and a 1. And if we check that, we're going to get negative 3v plus 5v, which is plus 2v in the middle, right? So if 3v plus 5 equals 0, v would equal what? Negative 5 over 3. And if v minus 1 equals 0, we would get
1.
positive 1. However, if we look up here, we said, oh, we can't have 1 in the denominator because then I'd have something over 0. And so we've got to get rid of that from our list. And so the only thing we're going to put in for that one is v equals negative 5/3. So number 4, 5, and 6, same kind of thing. I'm going to have fractions. And so I'm going to get rid of the fractions by multiplying by my common denominator. This time we have binomials up on top, so we get to do a lot more FOILing. And again, we have to check for our restrictions. So our restrictions on this one, I can't have negative 1 on the bottom of the first fraction, and I can't have a positive 3 on the bottom of that second fraction, or I'd have zeros down in the bottom of my fractions. So this time my common denominator is going to be u plus 1 and u minus 3. So I'm going to take the u minus 1 on the top of the first fraction times, this will cancel this, the u minus 3. Here, I'm going to take my u plus 1. This time the u minus 3 cancels, so I'm going to have to multiply that by u plus 1. Plus 1. And the 1 doesn't have a fraction to cancel, so I've got to use them both, u plus 1 and u minus 3. So foiling out the u minus 1 times the u minus 3. I'm going to have u squared. Negative 3u plus negative 1u is negative 4u. And then negative 1 times negative 3 is a plus 3. Foiling out that one, I'm going to have u squared. 1u plus 1u is 2u in the middle. And then 1 times 1 is 1. Here I'm going to FOIL that out. I'm going to have u squared. I'm going to have a negative 3 plus 1, which is negative 2u in the middle. And then 1 times negative 3 is negative 3. I would have to multiply it by what's in front, but in this case there's a 1 in front. So it's going to just stay u squared minus 2u minus 3. So u squared minus 4u plus 3 equals u squared plus 2u plus 1 plus u squared minus 2u minus 3. Again, I know I have to set it equal to 0. Since I have 2u squareds over here and only 1 here, I'm going to move these over. So I'm going to minus my u squared plus my 4u and minus my 3. If you want to combine your like terms first and then move them, that's all right too. So, u squared minus u squared and plus another u squared going to give me u squared when I combine all my u squareds. I got 2u minus 2u. Again, those are going to cancel, so I get just that plus 4u. I have 1 minus 3, so negative 6 plus 1 would be negative 5. So I get u squared plus 4u minus 5 when I combine all my like terms. Again, I have to solve by factoring. So u and u, since the end is negative, a plus and a minus. Factors of 5, I want a positive 4, so I'd have to have a plus 5 and a minus 1. So if u plus 5 equals 0, I'm going to get a negative 5 answer. And if u minus 1 equals 0, I get a positive 1 answer. Checking my restrictions, I didn't get either of those. So both of those should be solutions. So really long. Just take your time. Number 5 then, if I check my restrictions first, my restrictions would be negative 4 and negative 2. My common denominator is going to be v plus 2 and v plus 4. So on my first fraction, I'm going to take the v minus 1 times what?
V plus 4.
The v plus 4, exactly. The v plus 2 would cancel out, so I just have the v plus 4. On my v plus 2, I'm going to multiply that one by the v plus 2. The v plus 4 would have canceled out, and I'm trying to write that. v plus 2. And then my minus 1, I have to multiply by both the v plus 2 and the v plus 4, since I don't have a fraction to cancel either of them out. So foiling that first one out, what would I get when I multiply that all out?
V squared plus 3v minus 4.
V squared plus 3v minus 4. On the other side, if I multiply v plus 2 times v plus 2, I get
V squared plus 4v plus 4.
exactly v squared plus 4v plus 4. Then this one, FOIL that out first, then multiply by your negative 1. So if I FOIL that out first, I would get what?
V squared plus 6v plus 8.
V squared plus 6v plus 8. And then I have to multiply them each by negative 1. So I'm going to get a negative v squared, a minus 6v, and a minus 8, right? So I notice on this one that I have a v squared and a minus v squared that's going to cancel each other out. So I'm going to move everything over here on my left side because that's where my v squared is going to stay positive. So v squared plus 3v minus 4, I'm going to minus my 4v, minus that 4, add my 6v, and add my 8, and then I'll have everything over on the left side. So if I combine all my like terms, what am I going to get there?
V squared plus 5v.
5v, you said?
Mm-hmm.
And everything else canceled out. All right. I didn't do it, but I'll take your word for it. V squared plus 5v. If I have that and I want to factor it, what's the first thing I should do to factor that? It's not going to be a foiling one, right? Because it doesn't have the end number. I'm going to take out my greatest common factor. My greatest common factor is just a v. So I'm going to make this v times v plus 5. So either the v is just going to equal 0, I don't have to do much to solve that, or the v plus 5 equals 0, which gives me a minus 5, right? Look at my restrictions, I don't have either of those, so 0 and negative 5 are going to be my two solutions. So number 6, we're solving that one for y. First of all, if I pick out my restrictions would be 3 and 7. My common denominator, y minus 3 and y minus 7. So I'm going to take the y minus 1 times the y minus 7. I'm going to take the y plus 5 times the y minus 3, and I'm going to take my positive 1 times both of them, y minus 3 and y minus 7. And then I get to do a bunch of foiling. So, first one there, if I multiply that out, I would get y squared minus 8y plus 7. The second one, if I FOIL that one out,
Y squared plus 2y minus 15.
y squared plus 2y minus 15. And if I FOIL this part out, I'm going to get y squared minus 10y plus 21. I'm making Gavin do all the work. I'm going to multiply it by a plus 1, so that's not going to change much. Y squared minus 10y plus 21. All right, so I've got 2y squareds over here, which means I'm going to move that stuff over to the other side. I'm going to minus my y squared, add my 8y, and minus my 7. So if I combine my like terms, I'm going to get
Y squared minus 1.
y squared minus 1. And hopefully you recognize that as the difference of squares. How does that factor? Y plus 1 and y minus 1, and that means my two answers would be negative 1 and 1. If I look, doesn't match either of my restrictions, so those should be all right. having more fun with my fractions. These ones are going to have quadratic expressions in the denominator. I'm going to factor those out first so that I can see what my common denominator is. One of the factors are always going to match the one that's over on the other side there. But if I factor this one, I would have u and u, a plus and a minus, and I want the factor, or no, a minus and a minus. Better factor it the right way. Both of them are the same. U and u, minus and a minus, and 4 and 1 would add up to minus 5 in the middle. So my common denominator, u minus 4 and u minus 1. Again, I probably should check for my restrictions. My restrictions would be 4 and 1. So on this first part, both of these are going to cancel. I'm just going to get the negative 40 on top then. On the other side of my fraction, I'm going to take the numerator, that negative 2u. The u minus 4 is going to cancel, so I'm going to multiply it by the u minus 1. So negative 40 equals negative 2u squared plus 2u then. Again, I don't like my u squared to be negative, so I'm going to move everything over here to the left-hand side. So I'm going to have a positive 2u squared, a minus 2u, and a minus 40 equals 0. Now, I could try to FOIL that out right away, but if I recognize that there is a greatest common factor, then my numbers aren't going to be so big, and it's going to be way easier to factor. So I would go ahead and divide everything by 2, which means I'm dividing even that 0 by 2, but it's going to stay 0. And so I'm going to get u squared minus u minus 20 equals 0. And that looks a whole lot easier to factor than 2u squared minus 2u minus 40. Not that you can't factor that, but that's a lot easier. So factoring u and u, a plus and a minus. Factors of 20, I want a minus 1, so I'd have to have a minus 5 and a positive 4. Which means my two possible answers are negative 4 and positive 5. I had 4 and 1, which isn't either of those two things, so those both should be okay. Negative 4 and 5 should be my answers. So number 8, if I'm going to factor that one out, x squared minus 8x plus 15. I'd have an x and an x, my signs.
X minus 5 and x minus 3.
Both negatives, so x minus 5 and x minus 3 would give me the x minus 8 in the middle. So my restrictions would be 5 and 3. So on my first fraction, they're both going to cancel out. I'm just going to get the 8. On my second one, I'm going to take the negative 2 times what?
X minus 5.
The x minus 5. Since x minus 3 was in the denominator. So 8 is going to equal negative 2x squared plus 10x then. And so if I set that equal to 0, I'm going to move them over to the left. So 2x squared minus 10x plus 8 would equal 0, right? And again, I can divide all of those by 2. So x squared minus 5x plus 4 would equal 0. That would factor into what?
X minus 4 and x minus 1.
X minus 4 and x minus 1, which means my two possible answers would be 4 and 1. My restrictions were 5 and 3, which doesn't include 4 or 1, so both of those should be okay. So, number 9, if I factor out my right-hand side here, how does that factor?
That's minus 9. That's minus 2.
Or W?
Or-
Changed it to W minus 9 and W minus 2. So my restrictions would be 9 and 2. Gavin's the only one who wants to talk today. Yes. So I'm going to take the 2W times
W minus
which one? The W minus 9, because the W minus 2 is going to cancel, right? So times the opposite one. On the other side, both of those are going to cancel. I'm going to get the minus 28. Be careful you don't forget that negative in front, because it's easy to do. So 2W squared minus 18W, and I'm going to go ahead and move that over, plus 28 equals 0 then, right? Dividing by 2, W squared minus 9W plus 14 equals 0. And so that would factor into
W minus 7, W minus 2.
W minus 7 and W minus 2, which means my answers or possible answers would be 7 and 2. However, we can't have the 2 because that was one of our restrictions. So W is just going to equal 7. All right, we get to totally change gears, and that way we don't have such long problems. We're now going to solve things with radical expressions, and in order to get rid of the radical expression, we do the opposite of what's there. So in this case, with square roots, we do the opposite of taking the square root, which is squaring. We do have to isolate the radical before we try to get rid of it. So in this case, it's already by itself. We can just go ahead and square both sides. When you square that square root, it cancels out, gives me W minus 11. 5 squared is 25. And so when we solve that and we add the 11, W is going to equal 36. Now when you work with square roots and fourth roots, those with even exponents, you have to check your answers because sometimes you get what's called extraneous solutions. Normally they happen when you happen to square a negative. We squared a positive, so this one should be okay. If I take 36 minus 11, I get 25, and the square root of 25 is 5. Yep, it checks. So when we do number 11, the square root is not by itself. We have to get it by itself first. We're going to go ahead and add our 4 and say the square root of u minus 4 equals 9. Now that I have the square root by itself, I can square both sides. If I square both sides, what am I going to get? U minus 4 equals 81. So if I add my 4, U is going to equal 85. So 85 minus 4 is 81. The square root of 81 is 9. And 9 minus 4, sure enough, is 5. Yep, it checked out. So on number 12, first thing I'm going to do is subtract my 13. I would get the square root of u plus 7 equals negative 4. In this case, you may already recognize that if I have a square root, it's never going to be able to equal a negative number, right? You could stop there and say, oh, no solution. Square roots can't equal negative numbers, just like squares can't equal negative numbers. If you happen to go through and solve it, if you try to plug it back in and check it, it's not going to check either. But if you recognize that right away, hey, you get to be done. Now the next ones have two radicals. If you have two radicals, you want to make sure they're on the opposite side of the equal side, because you wouldn't want to try to have to square that craziness there. That would not be fun at all. Well, it might be, but it'd be hard. If they're on opposite sides, I can go ahead and square both sides. So squaring my square root gets rid of the square root, so 6y plus 8 equals 9y plus 7. And then I can go ahead and solve that. So I'm going to subtract my 9y and subtract my 8. Negative 3y is going to equal negative 1. And so when I divide, y equals a positive 1/3. Now these ones, again, you should check your answers just to be on the safe side. So 6 times 1/3 plus 8 would have to equal 9 times 1/3 plus 7. This would give me 2 plus 8, which is 10. This would give me 3 plus 7, which is also 10. So that's a good answer. Sometimes you'll get one negative and one positive, so you want to make sure you do check. Number 14. On this one, I've got my square roots on opposites, or on the same side. I want to make sure they're on opposite sides. So I'm going to move the negative one over here to make it positive. So I'm going to have the square root of 8x plus 15 equals the square root of 6x plus 13. And then I can square both sides. If I square both sides, I'm going to get 8x plus 15 equals 6x plus 13. So when I solve that, I'm going to subtract which one? 13. The 13, okay. Subtract the 13 and subtract the 8x. So 2 equals negative 2x. And when you divide, x equals negative 1. So again, if I just quickly check this, I'd have negative 8 plus 15, which is 7. I'd have negative 6 plus 13, which is also 7. It checks out. So I'm good. And 15, same kind of thing. I already have my square roots on opposite sides, so I can just square both sides. 7v plus 6 equals 5v plus 7. If I'm going to solve that, I would minus my 5v and minus my 6 or something like that. So 2v equals 1. And dividing, v equals a half. So that would be 3.5 plus 6, which is 9.5. That would be 2.5 plus 7, which is also 9.5. So it checks out. 16, 17, 18, same kind of thing, working with those square roots, and I want to get rid of the square root. Again, I want to have the square root by itself, which is it is, and I'm going to go ahead and square both sides. So v squared is going to equal negative 6v plus 27. Since I have a quadratic expression, I have to set it equal to 0. So v squared plus 6v minus 27 is going to equal 0. Factoring v and v, the end is negative, so a plus and a minus. Factors of 27, I want a positive 6, so a plus 9 and a minus 3. Which means my two possible answers would be negative 9 or positive 3. Now again, if I look at my original expression, I know that a square root cannot equal a negative number, so I could substitute them in and check them, but I know that the negative is not going to check. So in this one, or on this one, v is just going to equal 3. Did you want me to check it? You'll trust me? You guys are always so full of life. I can't believe you just don't think this is the funnest thing to do all day. You just sit there and go, yawn. Oh my God, is it over yet? If I square both sides on number 17, what would I have?
3v plus 28 equals v squared.
3v plus 28 equals v squared. I want to set it equal to 0. So v squared minus 3v minus 28. And if we factor that, it's going to factor into what?
B minus 7, B plus 4.
V minus 7 and v plus 4. So my possible answers would be positive 7 and negative 4. However, we know which one doesn't check?
Negative 4.
The negative 4. And so v equals 7, going to be my answer. And one last one. Squaring both sides, negative 5y plus 14 equals y squared, right? So setting that equal to 0, I would have y squared
Plus 5y.
is 5y minus 14. That factors into
Y plus 7.
y plus 7 and y minus 2 gives me plus 5 in the middle. So my answer
Negative 7 and 2.
-7 and 2 are my possible answers, but we know negative 7 is not going to work. So y equals 2. Got a question?
Threw in negative 7, wouldn't it be a positive 35 plus 14?
Where am I at?
18?
18. Positive 5 minus 14. Where are you at here?
Oh, like, with the negative 7, you said it won't work if you put it back in. But won't the negative 7 times the negative 5 make a positive 35?
It will, but you'll do 35 plus 14 then, right? 35 plus 14 would be 49. The square root of 49 is 7, not negative 7. That's why the negative won't work, because when you do the square root, it's always going to be a positive answer.
I got it,
Okay? Whereas the other one, if I check that, negative 5 times 2 is negative 10. Negative 10 plus 14 is 4. The square root of 4 is positive 2. Checks out. So, every time you plug the negative in, it's not going to check. The positive one should. But it's not that it's not good practice to check.